Hello everyone, here is our group presentation on EE435 Deep Learning course based on image style translation. Our group members are Tianqi Cai, Yuxiang Liu, and Genshin. To begin with, I believe everyone who have ever posted an image on Twitter, Facebook, or any other social medias have ever tried to edit images. With images edited, we can either have a much more beautiful image or a much funnier one. But look at this image, we could find that actually the style or contents of these images are not changed. Like we just simply put Rock Johnson's face on an egg, right? So what if we want to change the contents or style of an image? If we use our normal ways like Photoshop, it could take hours to finish the job. Fortunately, the introduction of deep learning ways could help us solve the problem. We've learned that image content and style can be separated by feature representation of DNN. So this allows us of a lot of ways to change the contents or style of an image. Our group have tried 3 of them, and I will show the results of them. The first and very beginning one is a neural style transform introduced in 2015. It's a very simple one, beginning with a random noise image, and after we determine the style image and the content image, we just let our input image to go through the network, and for each iteration we measure the difference between content and style separately. We could also add weight to the difference to determine which is more important, the style or content, with our experiment. The result looks like this. But there could be some problems with this method. The first is that whenever we change our content image or our style image, we need to go through all the iterations again. So it could be time consuming. The second is that we cannot focus on a special object in an image. We can only change the whole image with another style. So to solve these 2 problems, we would introduce 2 other methods. The first is called the real-time image transform, introduced in 2016. Instead of using just a simple loss function, the author actually established a loss network with the idea of perceptual loss. After we determine the style target, we could also pre-train the image transform net. So to use this, we just need to input our image, and it will go through the whole network with a simple forward propagation. And then we can generate our output image. The result looks like this. It does not have too much difference with the formal neural style transform one, but actually it's much faster. It only takes seconds, and it can easily change the style we need. However, it's still not solving the problem that we cannot focus on a special object. So here is our third method, which is called CycleGAN. Unlike a simple GAN, CycleGAN gives us a thought that we could put 2 symmetrical GANs together as a cycle. This gives a restriction that an image should generate to itself after it goes through the cycle. So it could prevent that something too real in picture A to be, which could be totally not related to picture B to be generated in picture B. So the results looks like this. We could change zebras to horses, and we could change satellites images to Google Map images. You can see that only objects who share similar features in 2 images would change the style. We've enclosed our main code for the image transform net with our report, as well as some more detailed description of the methods. Hope you enjoy it. Thank you.